Namaste to all. Welcome to my channel MA Tuitions. If you are watching my channel for the first time, don't forget to like, share and subscribe. And also don't forget to press the bell button, then only you will get the notifications properly. In the last class, we were discussing about fundamental theorem of arithmetic and their related problems. Today we are going to move into a new topic. It's not at all new for you. It's a topic. It's called irrational numbers. In the last class, you were already studied about irrational numbers and their properties. Let us recall that all. Root 2, root 3, root 5, pi, 0.101, 1001, 1001, etc. Just like this. These all are irrational numbers. You have already studied. I'll explain. What is rational number and irrational numbers? What is rational numbers? Rational numbers are those which can be written in the form P by Q, which can be written as a fraction, where P and Q are integers, and one more thing, Q cannot be equal to 0. Okay, so rational numbers are those which can be written in the form P by Q or as fractions, and the denominator must not be equal to 0. What about irrational numbers? Irrational numbers are those which cannot be, isn't it? Rational numbers are those which cannot be written in the form P by Q. Okay, these are the peculiarities of rational and irrational numbers. So these all are you have studied in your earlier classes. Then what is new in this chapter? In this chapter, you are going to prove that the irrational numbers just like root 2, root 3, root 5, etc. are irrational. Okay, you want to prove an irrational number is really irrational. Okay, so move on to the theorem. We have a theorem. We want to prove that, and then only we can move on to this. For that, we are using the fundamental theorem of arithmetic. Okay, fundamental theorem of arithmetic. Using that theorem, we are going to prove all these things are irrational. Move on to the theorem 1.3. Let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. Got it? P be any prime number, it is given. And P divides A square. A square may be any one number. A may be any integer. It is given that it is a positive integer. So we want to prove that if P divides A square, this P must divides A. For example, if 3 divides 9, 9 is 3 square, am I right? 3 divides 9, 9 is 3 square, then 3 must divide this 3. Am I right? Okay. So this we want to prove from this theorem, and we can use this theorem to prove the irrational numbers. Okay. So let's take A as a positive integer. Let A be any positive integer. And think that A is composite. A is a composite number. What is meant by composite number? Composite numbers are those numbers which have more than 2 factors other than 1 and the number itself. So A can be written as the prime factorization of a subproduct of some prime numbers. We have already studied in fundamental theorem of arithmetic. Every composite number, every number can be written as the product of prime numbers and which is unique, that we have already studied in the last class. So A can be written as some primes just as P1, P2, P3, etc. Pn as the product of P1, P2, P3, etc. Pn. And we want to find out A square. Okay, just find out A square. Then it will be P1, P2, P3, etc. Pn whole square. We can take this square into inside of this bracket. So you will get P1 square, P2 square, P3 square, etc. Pn square. That means A square can be written like this. It is given that P divides A square. P divides A square. It is given. which means a square by p is possible. This is possible. That is possible. So, which implies this p1 square, p2 square, p3 square, etc., pn square by p is also possible. You will get a number. If this is possible, this p must be equal to p1 or p2 or p3 or etc. pn. Okay, so we can write like this. P is a number in this p1 to pn. Okay, p is a number in this sequence. Which is given that A is, we want to prove that P divides A, you know. So, we know that A is P1, P2, P3, etc., Pn. We have already learned from this situation that P may be either P1, P may be P2, P may be P3 or Pn. This is OR. All these conditions not occur at the same time, only one. That means sometimes P may be P1 or P may be P2 or P may be P2, P may be P3 or P may be Pn. So for this condition also P may be included in this P1 to Pn. So we can say that. So we can write instead of this A equal to P1, P2, P3, inside this we can use P also and Pn. So we can write like this. P divides A. It is given that P divides A square and we have concluded in P divides A. This is the proof of this theorem. Next theorem, root 2 is irrational. We want to prove this theorem. So this we are going to prove in a contradiction method that we have already studied in the later classes. Contradiction method. For this we want to take root 2 as rational. We want to prove that root 2 is irrational, but we are taking as root 2 as rational number. By continuing like this, we will get into a contradiction because of the wrong assumption. In that stage, we will stop the proof and we will identify that root 2 is irrational. That is the method and contradiction method. Okay, so let root 2 be rational. Okay, here we are taking just root 2 as a rational number. We know the definition of rational number. Every rational number can be written in the form P by Q. So root 2 can be written in the form P by Q, where P and Q are integers. And one more thing is there, Q cannot be equal to 0. If P and Q have any common factors, sometimes it may happen, no need to be P and Q prime. So sometimes P and Q may have a common factor. That means you want to divide with the common factor. Root 2 can be written as A by B, where A and B are prime numbers. Okay, A and B are prime numbers. That means A and B do not have any common factors. And B cannot be equal to 0. So we got this root 2 as A by B. Then we will do one thing, we will just cross multiply. Then you will get root 2b equal to A. Root 2b equal to A. Just squaring both sides. Squaring both sides. What we will get? Root 2b whole square equal A square, which means this can be written as root 2 square is 2, b square equal to A square. From these we make an assumption that this 2 and the product of 2 and b square is A square. So we can say that this A square has a factor 2. That 2 divides A square. Isn't it? Just like this. A square by 2 is possible. This is possible. So we can say that 2 divides A square. In theorem 1.3 we have studied. What is that theorem 1.3? We have just studied that if 2 divides A square, then 2 must divide A. Am I right? 2 must divide A. 2 divides A. We got it. 2 divides A. So we got as A as the multiple of 2. Okay. Or we can write like this. A can be written like this, 2 into C. 2 divides A means A has a factor 2, or A can be written as the product of 2 and any other number. So we can be write like this, A equal to 2C. Okay. Now we want to put this A equal to 2C in this. Okay, we have root 2 equal to A by B is here, and substitute the value of A in this. So we will get 2C by B. Root 2 is equal to 2C by B. Just cross multiply, you will get B root 2 equal to 2C. Now squaring on both sides, you will get B square, root 2 square is 2. So 2B square, 2 square is 4 and C. Now we will get B square equal to 4C by 2, which is equal to 2C. B square equal to 2C. What does it mean? B square equal to 2C, which means B square is a multiple of 2 and C. That means B square is divisible by 2. B square is divisible by 2, or we can say that 2 divides B square. Am I right? 2 divides B square. 2 divides B square. Again we are using that theorem 1.3. We can say that 2 divides what? B. Here also we are using this theorem 1.3. So we can say that 2 divides B. Okay. So what does this mean? 2 is a multiple, B is a multiple of 2. Here we got A as a multiple of 2. So we can write this B as 2 into some D. B as 2 into D. So here we got A as 2C. Here we got B as 2D. But we have taken that root 2 as A by B, and A and B do not have any common factors. That means A and B are primes. From these two equations 1 and 2, we got just like this as at least 2 is there as a common factor for A and B. Got it? A and B have at least one common factor, which is 2. Which is common factor which is 2. So this is a wrong assumption. This is a wrong one, because we got this due to our wrong assumption that root 2 is rational. So we can conclude that root 2 is not rational. That means root 2 is an irrational number. We got here A as the product of 2 and C. Here B as the product of 2 and D. If we are substituting here 2C by 2D. Here A and B both have the factor as 2 in common. Since A and B are primes, there should not be any common factors to this A and B. This happened due to our wrong assumption that root 2 is a rational number. So we have to conclude here, we must say that root 2 is not an rational number. It is a irrational number, which is an irrational number. Got it? Prove that 5 minus root 3 is irrational. For this we are using the contradiction method. So we are taking this 5 minus root 3 as a rational number. 5 minus root 3 as a rational number. 5 minus root 3 as rational number. Okay. Then every rational number can be written as the form P by Q. So we are taking this 5 minus root 3 as P by Q, where we are taking this P comma Q as prime numbers. Prime numbers and Q not equal to 0. These are the conditions. P and Q don't have any common factors. So we will write just like this, negative root 3 will be equal to, no need to write negative root 3. We can take this negative root 3 into this side and P by Q to this side. So it will be 5 minus P by Q equal to root 3. Okay, 5 minus P by Q equal to root 3. And this 5 is a rational number. Am I right? Rational number. P and Q are also rational numbers. Am I right? The sum and difference of rational numbers are always rational number. Then 5 minus P by Q must be a rational number. Which means root 3 must be is a rational number. Rational number. Root 3 must be a rational number. Is that right? Is this right? No. We know that root 3 is an irrational number. That we all know. Irrational number. This happened because we have taken just like this as 5 minus root 3 as a rational number. So due to our wrong assumption, we concluded in root 3 as a rational number. This is wrong. So we have to say that 5 minus root 3 is irrational. So we want to write 5 minus root 3 is irrational. Hence the proof. Exercise 1.3, first question, prove that root 5 is irrational. This we want to prove just as the root 2 as a rational number we have already discussed. Then also I am doing this. Just take root 5 as rational number. Root 5 is a rational number. So root 5 can be written just like this, which is P by Q, where P comma Q are primes and Q not equal to 0. This is our condition. Now what do you want to do? Cross multiply. Am I right? Root 5Q equal to P. What is the next step? We have done in the root 2 as a rational, you know, that theorem 1.4. So we want to square. Squaring on both sides. We will get root 5 square is 5. Q square is this. And this is P square. So what we have got from this? P square is a product of 5 and Q square. Or we can say that 5 divides this P square. What does this mean? 5 divides P. 5 divides P square means 5 divides P. Here we are using the theorem. Theorem 1.3. You want to state that theorem here. Okay. If P divides A square, then P divides A. That you want to write here. So we got 5 divides P. So we can write this P as 5 into R. Okay, this P can be written as a product of 5 and some number 5R. And substitute this P equal to 5R in this. Then we will get root 5 equal to, instead of P we are using 5R by Q. Okay, we are using this P equal to 5R. Substitute in root 5 equal to P by Q. So we are getting root 5 equal to P as 5R by Q. Then again cross multiply root 5Q equal to 5R. Again you want to squaring. Squaring on both sides you will get root 5 square is 5 and Q square is Q square itself. 5Q square equal to 5 square is 25 and R square. 5 is common to both, so it will be Q square equal to 5R square. So you got Q square equal to 5R square. What does this mean? Q square is the product of 5 and R square, which means 5 divides what? Q square. 5 divides this Q square, which means 5 divides Q using theorem 1.3. That means if P divides A square, then P must divide A. So we got two conditions. One, 5 divides P and then 5 divides Q. What is the meaning of these two sentences? That means P has a factor 5 and Q also has a factor 5. So we have already discussed already we have taken P and Q as a primes, which cannot be have any factors, common factors. But we got just like this as P and Q have at least one common factor, as 5. Both P and Q got 5 as a common factor. This is a contradiction. to the assumption that this P and Q are prime. This is a contradiction. So we can say that this happened due to our wrong assumption that root 5 is rational. Next question, prove that 3 plus 2 root 5 is irrational. This also we are using the contradiction method. Just take 3 plus 2 root 5 as an irrational number, rational number. We want to take just the contradiction, rational number. Then you know that every rational number can be written as the form P by Q. So 3 plus 2 root 5 can be written in the form P by Q. Okay, 3 plus 2 root 5 can be written in the form P by Q. Here root 5 is an irrational number that we all know. So we want to make this root 5 only here and all the other numbers to that side. So 2 root 5 will be equal to P by Q. This 3 will go there and it will be minus 3. And what about this? This will be P minus 3Q by Q. Just cross multiply. Then root 5 will be P minus 3Q. By this 2 will be here. Then it will be 2Q. Okay. Then you got this root 5 as P minus 3Q by 2Q. We know that P, Q, 3, 2 all are rational numbers. Rational numbers. So which means P minus 3Q by 2Q is a rational number. A rational number. But the answer of this P minus 3Q by 2Q is root 5. So from this we want to write root 5 equal to a rational number. But this is a wrong one. This is a wrong assumption. Root 5 is not rational. We know that root 5 is not rational. Why this happened? Because of a wrong assumption that 3 plus 2 root 5 is a rational number. So we can say that 3 plus 2 root 5 is irrational. Due to our wrong assumption that, what is that? 3 plus 2 root 5 is a rational number. Because of that, we got just root 5 as the rational number. So we know that our assumption was wrong. So we change this assumption as 3 root plus 2 root 5 is irrational number. Got it? Next question, prove that 1 by root 2 is irrational. So we want to take 1 by root 2 as a rational number. We are taking this 1 by root 2 as a rational number. So every rational number can be written as the form P by Q. So we are taking this 1 by root 2 as P by Q, where P and Q are primes and Q not equal to 0. So we can take this reciprocal of these two terms. That means root 2 by 1 equal to Q by P. Or we can say that root 2 equal to Q by P. Since Q, P are primes and they are rational numbers, we can say that Q by P is a rational number. Okay. A rational number by a rational number is a rational number. But this root 2 is not rational. Okay. Root 2 is an irrational number. That we know. So we can say that this happened due to our wrong assumption that 1 by root 2 as a rational number. So our proof is that 1 by root 2 is really an irrational number. Actually an irrational number. Got it? Next question, 7 root 5 is an irrational number. We want to prove that 7 root 5 is an irrational number. So we are taking this 7 root 5 as what? A rational number. 7 root 5 as a rational number. Then 7 root 5 can be written as the form P by Q, where P, Q are primes and Q not equal to 0. P, Q all are rational numbers. So we can take the 7 to that side, then it will be P by 7Q. Since P, Q, 7 all are rational, what we can say, this P by 7Q is also rational. All these numbers are rational, their operations must be rational. So we can say that root 5 is also rational. Then you will get this root 5 is also rational. Is this correct? No, we have already proved that root 5 is not a rational number. Why this happened? Due to a wrong assumption. Okay, so what we can say that root 7 root 5 is an irrational number. Irrational number. Got it? What happened? 7 root 5 is, we are taking the 7 root 5 as the rational number. Then we can write the 7 root 5 as P by Q form. And this root 5 can be written as P by 7Q. We know that P, 7 and Q are rational numbers. So their operation, that means P by 7Q must be a rational number. So we know that P by 7Q is root 5. Isn't it? P by 7Q is root 5. So if this is rational, this also must be a rational number. But this is wrong. This happened only because of our wrong assumption that 7 root 5 is a rational number. So we can write 7 root 5 is an irrational number. Last question of the exercise. Prove that 6 plus root 2 is an irrational number. So we are taking this 6 plus root 2 as a rational number. By contradiction method we are going to prove. So take this 6 plus root 2 as a rational number. And we can write this 6 plus root 2 as, we have already discussed, you know, P by Q, where P and Q are prime and Q not equal to 0. Then we can take the 6 to that side. So you will get root 2 equal to P by Q minus 6. Here also P, Q, 6 are all real numbers. Real numbers. So we can write P by Q minus 6 equal to a rational. No, this is rational, not real numbers, rational. Rational number. So this is a rational number. What is the answer of this P by Q minus 6, which is root 2? So root 2 is a rational number. All the questions are doing on the same manner. Okay. Rational number. This is not correct. It is not correct. This happened due to our assumption that 6 plus root 2 is rational. So we can write 6 plus root 2 is an irrational number. So this was the last question of exercise 1.3. So today we have discussed about this exercise 1.3 using a fundamental theorem of arithmetic. We were discussing some theorems regarding the rational number. Theorems was theorem 1.3 and 1.4. 1.3 says just like this. If P divides A square, then P must divide A. A is a positive integer. And what about theorem 1.5? Root 2 is an irrational number. So we have studied whatever may be the irrational numbers you are given. You can easily prove that they all are irrational numbers using the fundamental theorem of arithmetic and the theorem 1.3. So go through the problems, study well. If you have any doubts, please mention on my comment box. And thank you so much for watching. We will see you on the next video.